Bismillahirrahmanirrahim. Assalamu alaikum dear students, welcome back in lecture 4. Student, as we started equivalent frame method, and in lecture number 3 basically we calculate this coefficient m, okay, and we ends here, okay, at this coefficient, okay, that is 0.084. How we basically calculate that coefficient, let me show you again, because that is the part of lecture 3, okay. So here we have this table, okay. From this table we basically choose these values as you see in this Excel sheet. We choose this value from sheet this one, and let me show you here. Basically we have to find the value of m from that table, okay. That is the coefficient which will be used for calculating the fixed end moment. As you already know that fixed end moment is equals to WL square by 12. So here the coefficient 112. In this lecture basically when we are calculating the fixed end moment, we do not use this coefficient, that is equals to 0.083. clear? So we will use this coefficient, okay, this one. Our fixed end moment will be 0.084, clear? WL square, clear? So what we basically did, we choose this value from table, similarly this value from table, similarly this one and this one, clear? Then we interpolate this value, clear, and this value, clear, and then using the two-way interpolation technique we calculate this value, okay. I already explained how to use two-way interpolation and one-way interpolation technique in lecture number 2, clear? So please go and watch those videos, clear? I already insert the formula. You see this value is basically calculated in between this value and this value, similarly this and this one, clear? Similarly you see this value is calculated by using this one and these three values, clear? And the final value will be used by two-way interpolation. You see these values, okay, this, because if we don't calculate this value and this value, we are unable to find this value, clear? So next what we have to do, similarly you have to find this KAB and COF from the same table, okay, from the same table, from this table, okay, by this interpolation technique. Next we have to calculate moment of inertia of this T section, okay. What you need, you have to calculate the centroidal distance, then using the parallel axis theorem you find out this value, clear? And the next one, okay, one thing more which is very important to share with you. If you search these notes on your Google, you find this graph. This graph is basically used to find out the moment of inertia of a T section, clear? You see IB, moment of inertia of the T section. Here you have CT, here you have these curves which is selected on the basis of HF to H ratio. HF what? That is the flange thickness, and H is the total overall thickness. And similarly you have to calculate this CT coefficient, which is calculated from this equation. And where, what does it AB means? You see A equal to B by BW and B equal to HF by H. So find out these values, choose the one, and you can easily find your IB value by just finding CT value, plug that value in this equation, you found that you found this value, clear? I is B, clear? The next one is the moment of inertia. I already explained this equation in lecture number 2, I think, yes. So go there and how to use this equation, clear? Then the moment of inertia of slab, I already explained this in lecture number 2. KSB is now the stiffness of the slab beam, clear? So the value which you found out for KAB, now you plug that value. ECS ISB is calculated, which is this one, and L1, you see all the values, just do the calculation. you got this one. Clear? Now the very important point is this one, that as all the spans are equal, so that why we don't need to go and to calculate the values of the rest of the spans. Clear? All the spans are same, so that why we don't need to calculate the rest of the values for BC and CD. It should be remember, if BC, CD, DE spans are having different lengths, span length, you must have to calculate IS B, IS values and the rest of the calculation for KSP. Clear? Next, what we need KEC, that is the relative stiffness. I already uploaded two examples in lecture number 2, how to calculate KEC. So for thorough explanation, if you are interested, so please watch lecture number 2. Here I am not going in detail of these things, okay, but as we have two columns here, the one is located at B point and the one is located at A point. So we have interior column and we have exterior column or H column. So this is our C2 and this is our C1. So we have to find out KEC for this one, similarly KEC for this one. Clear? So this table is clear. I already explained this, and now we need KEC. For KEC we need KC and KT. So we need KT. So for KT, as we have C1 and C2 column, so that why C2 and C1 will be calculated. For this we need KT. Now we need C value. So C value, I basically how to calculate a C value. So you see we have an H beam and we have a T beam, because you see in this figure, in this layout, we have one interior beam and we have one edge beam. So the cross section of the transverse beam over this column will be looks like an L shape, while over this C1 the cross section of a transverse member will be looks like in T shape. So we need to use T shape for this C1 and we need to use L section for this C2, and from that we will calculate the value of C. So how to calculate a C value, I already uploaded lecture number 1. Go there and find out how to use C in case of L section and how to use C, how to calculate the value of C in case of a T section. But one thing I will share you, this cantilever portion will be equals to this one. Clear? And here we are using option B. So what is option A, what is option B? I already explained this in lecture number 1. So next is a T section. In T section we have also option A and option B. Okay, so go there and find what is option A and what is option. The option B is this one. Okay, we use this total section and these two one. Okay, now the cantilever portion will be equals to this one. Okay, the total width of this T section, this portion, that is the flange portion, is BW plus 2HW or BW plus 8HF. So we have to select the minimum value, and the minimum value will be 40 inch. Now just subtract this 14 inch, you got this cantilever portion. Okay? And then divide this in section number 1. In section, this dotted one will be one section, and this the section having a slash lines will be our section 2. And using that formula of the C, you find out 12694, and this one is 11284. As you already see in this lecture, 11208 and 12694. From where these values comes, I already explained it. Okay, so now you just need to, as the C value is calculated, you just plug the value in this equation. C2 is already known, L2 is already known, and you plug the value, you got the answer. Clear? You see here. Remember, you have to multiply it by 2. Why we multiplying this by 2 and why we not? So I already explained this in lecture number 2. Similarly, kt for c2 and kt for c1. But one thing more which is very important, you have to multiply this factor. Why we multiplying this factor? Because you see that here we have the beams exist in the analysis direction or in the span direction, so that why we are compelled to use, this is the restriction of the equivalent frame method or as well as the ACI code, that you have to increase your kt by multiplying this factor. Clear? So our kt will be this one for c2 column, remember, and for c1 column it will be this one. Clear? This one. So, and you have to multiply that factor. Okay, and here we have, you see, 3792 and 4295. Clear? The next one is kc. Okay, so kc is the equivalent, you can say equivalent stiffness of the columns. Okay, so here we have bottom column, top column. Clear? So we have to calculate it. First of all, we need IC. So you see our column section is 14, that is a square section, so just keep power 4 divided by 12. You got this one for both c1 c2 because the cross section of the both column is same. Clear? Now we need LCLU. What these means, so I already explained this in lecture number 2. Let me show you here. You see LU for, let's say for example, we calculating for this floor, that is our interior floor. Okay, now for this interior floor, our LU and LC. Okay, remember for bottom column, this is bottom column, this is top column. Clear? I think so it calculated for the column heights are same for all stories. Okay, this is a good news. Okay, for top and bottom of c1. Now for c1 column, what will be the top and bottom? As we know that our heights are same, so that why we don't, our LCLU will be same for all stories. This is good news. Okay, because sometime it is different. I already did one example in lecture number 2. Okay, when it different, so you have to it will lengthen your calculation. Clear? So LU is clear height. Okay, from the, remember this point is very important. Okay, from the bottom of the beam, or you can say from the bottom of the web of the beam, LU. Clear? And LC is the center from the slab center line to the lower floor center line, slab center line. Clear? You see here LC. So LC 106, LU will be equals to half from this side and half, okay, that slab plus the height of the width of the beam. Clear? So you will find your LU and LC. So the most tricky part to calculate the Kc value is the value of Tb and Ta, as we have column below the floor and column above the floor. As we are calculating the Kc value for this floor, that is our interior story, our interior floor. So in this case, this column is our bottom column and this is our top column. But if let's say this is my top story, if I am doing calculation for Kc in case of the top story, then remember I have no top column, I have only bottom column. Clear? So if the heights of the floors similar, okay, as in this case height is constant, so the Kc value which is calculated for this bottom column will be remain same for this column as well in the case when we do calculation for Kc. You will see inshallah next. So now as this is our point of interest story, okay, our interest story, so that why here we have to choose Ta and Tb value. Clear? We do calculation for this lower column. Now remember this is point of interest, so that why our Ta value will be now here for bottom column. Okay, so this value will be our TA, this one, you can see this one, clear? And TB value will be this one. So TB is 7 inches as the thickness, so 7 divided by 2, that is TB. And TA is how much? You can get this value by, as I already do this here, okay, 20 is the overall depth of the beam minus 3.5 inch cover from the top of half of the slab. So you got TA value will be this one, TB will be this one. Now you have to find out your ratio of TA, TB and LC, LU as we did in lecture number 2, and using table S17. Remember, for calculation of KC we have to use table S17, and for calculation of case B we have to use table A14. Clear? Now go to McGregor book and find out that table. Okay, this table is used for case B and this value table is used for case C. You see, case is equal to K times E times I, let me show you, IC divided by LC. Clear? So we need to find out the K value. K value will be found out by using these values, TA by TB, this one, and LC by LU ratio. So in our case, here we are lucky because our TA by TB value, although this one LC by LU value 1.20, which coincides with this value 1.20. So here we are lucky. If it lies in between these two values, so we need two-way interpolation. But here, as our value is TA by TB is 4.71, that's why we need to interpolate 4.71. That is, we need to go down here, okay, go down here, and 4.5 and 5, okay. So we have to interpolate the value in between these two values. So I already show you all the values. You see 4.5 and 5. So the K value in front of 1.15 and 1.20, the K value is this one. It is from table. This value is from table. Now this value is from table, and similarly this value is from table. We just need one-way interpolation. We have to find out this value, okay. So I already do the calculation using one-way interpolation, okay, and this is our K value. You just need to plug that value in that equation of Kc for lower column, okay, and you find out your Kc value for lower column, that is 192. Similarly, do the same calculation for the top column. As I already, this one is our top column. So here, what things will be changed? Only TA and TB value will be changed. This is our point of interest, or interest story. So that why TA now will be here, this one, okay, this one, the small one, 3.5, and TB will be now this one, clear? That is 16 point. So this only T and TB values changes, okay, for in case of Kc calculation. You see, T and TB, you just need to find out the values, ratios, and here we are also lucky because 1.5 coincide with that value. We just need to find out 0.21 in table S17. The value which I calculated is 5.3. You just need to plug Kc for top. You see here 135. So if we come to this lecture, you see C1 for bottom and C1 for top. LC values are same, LC LU, okay. TA by TB value, this is 4.71 for bottom and this one is for top. Clear? The KB value is this one, and KB, this is interpolated value, I already explained. So you see for C1 column 192 and 135. Following the same procedure, and you find the value for C2, and C2 for C2 it also will remain same, clear? If let's say for example the C1 column is different, okay, C1 C2 column is different, where there is no beams or the beam web depth is changed, okay, so then you have to repeat this procedure for C2 column as well. But as there is the geometry is same at C1 and C2, or the beam widths depths are same, okay, so that's why we don't need to go for calculation of C2, okay, we will use the same values. Clear? Similarly, now Kc for C2 column. So for C2 you see Kc, this is very important that Kt is different for C2 and C1. So that's why basically it changes Kec from for C1 and C2. Clear? So you just need to flag out the values. Remember, ECS is the modulus elasticity of column and ECS for slab. All these strengths of the concrete is same. That's why we just only one value, that is EC. Clear? So here you see, it should be remember, we have to find out summation of Kc for the lower, which is the sum of the lower and the top one. Clear? This one will be 3 to 5. The strength is same, that is 3 KSI, so that's why. Okay. And so similarly for column C1, as we did calculation for C2, this one, okay, we got this value for C2, and similarly for C1 we have this value. Clear? Now you just need to divide this value by this one, okay, add up and bring this KEC here, and that the value which is calculated from these values will bring here, and divide 1 by that value, you got KEC. Okay, because some of students may confuse how to find out KEC. Okay, so this is the final values for interior story. Okay, and this is also good news that the stories are, the ground stories and the interior story is similar, so we will assign the same value of case B and case C for to the ground story as well. Clear? This means that this KEC value will be here, similarly this one will be here, and this one will be here. Okay, and for the rest one, and K is B. Okay, as there is similarity, or you can say similarity in geometry, mean the beams at ground story and interior story and the top story is same, the slab thickness is same, the beam depth is same, so that's why 349 will be here for this story as well and for the top story as well. Clear? So the case B will be same. This is also show the importance of similarity in geometry, because if you are keeping, let's say you are designing any system, okay, any structure, so you have to keep similarity in structure, if in geometry, because if you keep that similarity in geometry, it make easier your calculation. Clear? And let's say if you assume that the beam dimensions, the slab dimensions, the column dimensions is different from ground story, interior story and top story, so imagine how much calculation you need at this point. This why we have to use similarity in geometry. Clear? Which will make easy your calculation. Clear? So here you see the ground story is similar to the interior story, that we need just only to calculate. We don't need to calculate any values of KEC and KSB for the ground story, but we need to find out the KEC value for the top story, because you see here, as already you see, we find out summation of KC, which is the summation of lower column plus top column. Now here you see, we in the case of the top story, we don't have any top column, so that's why our K value will be different. But already I explained, if there is symmetry in story heights or in floor heights, so the value which you find out for your bottom column will be same for your top column. Okay, so that's why we are lucky here, because there is similarity. If, let me show you the calculation how to find, let's say if there is not non-similarity, means the ground story height is different from the top story, then you have to use the procedure. Remember, this is very important, that here is the point story of interest. Now you see here, we are calculating the value of Kc now. Sorry, Kc, yes, Kt will be same, but only we need Kc. So here Ta value will be changed. Remember, Ta value will be this one. This value will be now our Ta value for top story. Remember, this is the only tricky point. Clear? This value is now Ta, and this value will be now Tb. The small value, that is this value, that is now Tb. That is 3.5 inch. Okay, this is 3.5, and this one will be 16.5. Okay, so as in the case of lower column, the Ta value is also 16.5. Okay, and the Tb value is also 3.5. Okay, as in the top story case. Okay, so that's why it due to this similarity, we have the value of K will be same as the one which we calculate for this column, that is the bottom column. Clear? So here you see what will be our Ta value and what will be our Tb value. LC LU will be remain same, and go to the same table, that is table S17, and find out that value. Okay, if these LC LU are changed, okay, if it is same to your bottom column, so you don't need to go for the calculation. Our value of K will be same as we did for lower column. Okay, so now Kc will be the same. Summation of Kc, now you see the difference is this one. Clear? In that case, basically for the interior story, this value is changed. Clear? Now for C2, our value is 182, and for C1, our value is this one. Clear? Now you just need to assign all the values. You see here, this black color is the case B value, which is assigned to the beams, and these blue color, you see the values which is assigned to the columns. You see the difference in KEC value. For our interior story and ground story, KEC is 301, 301 for the C2 column, and this is 182. For C1 column, you see 183, 303, 303. So these two values is same, while this one is different. And this winds up basically our equivalent frame method. Remember, okay, this ends up equivalent frame procedure, which transform a 3D frame to a 2D equivalent frame. This is a 2D equivalent frame. It basically, actually, we convert a 3D frame to a 2D frame. This is the way, this is the procedure, that how to convert, okay, a 3D structure to a 2D structure. This is a 2D structure. Okay, and now you are allowed to assign this model in SAFE or ETABE and do the calculation. This is a right procedure. Okay, or just, okay, that procedure is wrong if somebody extract any 3D frame, model that frame in SAFE or ETABE, okay, and without doing this calculation, okay, that procedure is wrong. Okay, this is the procedure. Now in ETABE, in SAFE, you have to assign these stiffnesses to your structure, and that will be now your actual model. Okay, this is the way of transformation of a 3D frame to a 2D frame. The next step, to use moment distribution method to analyze the frame for moments, and you will see, okay, in next lecture, that is lecture 5, how to use moment distribution table and how to find out the loads and the rest of the procedures. Thank you for watching.